Good morning, everyone. First of all, thank you so much for joining this workshop. I'm Rahul Sharma, Associate Consultant at Infosys. You can scan this QR code and connect me on LinkedIn. I would like to welcome all of you to the Agentic AI in DevOps workshop. Today's session is going to be very different from typical AI talks. We are not just going to discuss ChatGPT prompts or theoretical concept. Instead, we will be understanding how AI actually works behind the scenes, how LLMs models use tools, what AI agents are, what MCP servers are, and most importantly, how DevOps engineer can use agentic AI to automate real world operations. By the end of this workshop, you will not only understand these concepts theoretically, but you will also build your own AI powered DevOps agent practically. So let's get started and explore the future of intelligent automation together. Now, let me quick walk you through today's agenda. So, this session So in this session, first we will start with the AI evolutions and the basics. We will understand how AI started back in 1956 and how AI is evolved from simple rule-based system to the modern intelligent system. Then we will move to machine learning and deep learning. Here, we will understand how machine learns from data, how neural network work, and how deep learning help in creating modern AI models. After that, we will discuss LLMs and generative AI. In this, we will talk models like GPT, Gemini, Claude, Llama, and understand how these models generate human like responses. In this, we will understand how DevOps is evolved, like DevOps to MLOps to AIOps, and how AI is transforming infrastructure and operations. And in MCP and tool calling, we will understand what MCP is, how AI models use tools, how LLMs communicate with external systems. After that, like in agentic AI in DevOps, we will see real world use cases like how AI agent can monitor Docker container, analyze logs, and automate operational tasks. And finally, we will do a complete hands-on demo where we will build a real DevOps AI agent using Olama, LangChain, Docker, Python, etc. So, by the end of this workshop, you won't just understand agentic AI theoretically, you will actually build one practically. So, let's get started. Introduction to Artificial Intelligence. Artificial intelligence officially began in 1956 during a famous Dartmouth conference. This is considered the birth of AI. Artificial intelligence is a field where machines such as computers, mobile phones, and softwares systems are designed to behave like humans. Humans. Humans can think and act based on situations. For example, if it is a rain, take the umbrella. Human observe situation, understand them, and make decisions. Likewise, AI is a domain that tries to mimic. or replicate human behavior. After AI, another important domain emerged inside AI, which is called machine learning. And from here, the journey of AI started. Machine learning is a subset of AI where machine learns from data. Instead of programming every step manually, we train machines using data so they can make predictions and decisions on their own. For example, think about your school journey. In junior classes, you learn A for apple, B for ball. Later, teacher asks you to form words. Then, in higher classes, you started forming sentences. You were not generating everything automatically from day one. You learn by reading books, you observe examples and practice repeatedly. Machine learning works in the same way. Machine learning learns patterns from data, like humans learn from experiences. Then, inside machine learning, another branch was introduced called deep learning. Deep learning is inspired by the structure of a human brain. It uses actually artificial neural network to process complex tasks such as images, audio, text, videos. Just like our brain has neurons that receive information, store information, process information, and pass information forward. Deep learning model also works similarly using layers of neural network. These neural network uses conditions, data processing, memories, and decision making mechanisms. Because of this training process, deep learning creates models. Let's take example of our school journey. Like in first standard, we learned about alphabets. In second standard, we learned about words. Later, we started forming sentences. Then, in higher classes, trained us about advanced concepts like math, physics, science. We learn lots of things. Similarly, deep learning models are trained step by step using data. This training process creates powerful AI models, right? And then later, engineers realized if humans can learn from text, images, audios, then machine also learn the same way. So they started feeding huge amount of data into these models. This eventually led to creations of LLMs, which is large language models. Large language models. Large language models are the advanced AI system trained on a massive data sets to understand and generate human-like text. We have popular LLMs are like GPT-4, GPT-5, Claude, Gemini, DeepSeek, Grok, etc. They mainly work by predicting the most likely word or token. That prediction capability eventually led to what we call generative AI. Because of these systems automatically generate text, images, audios, videos, and more. So I hope you understand how the things evolved. As of now, deep learning creates models. Models are trained on a massive data sets. These models started generating outputs. This gave the birth of generative AI. Let's take an example. If we ask a model, who is the goat of a cricket? Who is the goat of a cricket? Everyone knows. Sachin Tendulkar. This means the model can generate content that become generative AI. Few examples of generative AI are Ghibli images, everyone creates, AI chatbots, AI coding assistant, right? So now let's come to a demo part of generative AI. Let's stick to the screen and see like how generative AI works basically. Now let's till now we understand what LLMs are, what generative AI is, and how models generate responses. But now the question is, how do we actually interact with these AI models using code? So let's build a very small AI chatbot locally using Olama and Python. Here I have built one chatbot. Importing Olama. Here I am importing Olama package. Olama is not a large language model. It's an application that allows you to run models like Gemma, Llama, DeepSeek, etc. locally in our system. So this package helps Python to communicate with the Olama server. Right now, the system prompt. This is the one most important concept in the generative AI system prompting. A system prompt is basically a master of instructions given to the AI model. We are telling the model behave like Docker expert, give short answer in 1 to 2 line max, explain the errors, root cause, and explain the fixes as well. So instead of making the model answer everything in the world, we narrow down the model for a specific role, which is Docker expert. And now we created a one loop. While loop allows us to continuously chat with the AI, and we take a input from the user, and in the if the user type exit, then the loop will break, and we came out from the model basically. So let's come to the main part. Here we are calling Olama chat API. This API sends our request to the model, and in the model we specify which large language model we want to use. Here we are using Gemma 4 model. And in the messages, LLMs work using conversation history. That's messages are passed in the list formats. And now come to the user role, content, user input. This tells the AI these are the this is the actual questions coming from the users, like we are passing user input here itself, and it will tell you like it will tell the actual questions coming from the user. So internally the model receives and then generates the response. And at the end, what we will do? Print. The model returns lots of metadata like the timestamps, tokens, model info, but we only want a particular output. The so we print only the content part here itself, right? So what I did is I executed this generative AI.py file and asked this model like who are you and what all you can do. See the answer. Like I am a Docker expert. I optimize container images, solve networking issues, and write efficient Docker files. How cool is this? How cool is this? Now I just give one Docker error. Like this, it's a journal common error. Journal got a permission denied issue while trying to connect to the Docker daemon socket. Everyone faces this issue, right? So see the output here. User account lack of necessary permissions to access the Docker daemon sockets. What will be the cause? You are not a member of a Docker Unix group, and it will give you the fix as well. It will give you the command to fix this issue, right? So how cool is this? We built a Gen AI app, right? So moving forward, now let's understand one of the most important transformation happening in the industry right now. DevOps to the MLOps, MLOps to the AIOps. Earlier, as DevOps engineer, our primary focus was application delivery and infrastructure automation. Our traditional DevOps pipeline usually looks like code, build, test, deploy, and monitor. You can see on a screen. This is the standard CI/CD lifecycle most of us already know. But when AI and machine learning start becoming popular, companies faced a new challenge. They realize deploying an application is different from deploying machine learning models because in machine learning, data changes continuously. Models need retraining, accuracy validation is required, models needs monitoring after deployments, and that's where MLOps came into a picture. So instead of code, build, test, deploy, the pipeline became data, train, validate, deploy, monitor. Now, here monitoring is very important because ML models can drift over time if the data changes. To manage these workflow, engineers started using tools like Kubeflow, MLflow, DVC, etc. These tools help automate the machine learning lifecycle. Now, next evolution is AIOps evolution. AIOps using AI itself to automate the IT operations. For example, intelligent monitoring, automatic alert analysis, root cause detections, self-healing infrastructures, AI agent handling operational tasks. Earlier, humans used to monitor systems manually. Now, AI systems can analyze logs, detect anomalies, predict failure, failures, take automated actions. And this is exactly where agentic AI becomes powerful for DevOps because now we are moving from automation script to intelligent autonomous systems. Today, this workshop is focused exactly on that. Now, LLMs are the advanced AI systems we already know, right? But they trained on historical data. For example, if I ask any LLM model, like who is MS Dhoni, everyone knows. Like in the same way, the LLM can answer because that information already exists in the past data. But what if I ask LLM, what is the current time right now? What do you think? LLM can answer? No. Traditional LLMs cannot answer correctly because they do not have access to the live data. Like I give you example. Um, let's go back to the code as well. Like this, we created Gen AI and we use Gemma 4 LLM here. In that, like I ask, what is the current time right now? So see the output. I cannot provide the current time. I am here to help you with the Docker errors. Traditional LLMs cannot tell us current time because they are not have access to live data. So in 2024, let's go back. So in 2024, Anthropic realized that LLM only works on a past data. They needed a way to provide live context, real-time information, external tool access. So they introduced Model Context Protocol, MCP. MCP allows LLMs to communicate with tools. Suppose you have one LLM which we just created, and you have a Python function called getCurrentTime. When a user asks, what is the current time? The LLM itself may not answer, but modern LLM can because they can detect missing information, call tools, receive the tool response, and generate the final answer. This process is called tool calling. And and with this combination of LLM and tool is known as agent. How cool is this? Means agent is a combination of LLM and tools. That's the agent. Let's take example. Let me more clarify. We use the JAMA model. We create a tool show running container, right? Initially, the tools runs Docker PS to get the running container data. If you are a Docker engineer, you already know. Like to get the running containers, we manually hit docker ps command and then we get the output. But if the user asks how many Docker containers are running to the LLM, can LLM answer alone? No. But if we ask Gemma to access the Docker tools. Like it calls the tool, get container information, and respond correctly. What do you think? It will answer? Yes. This is a combination. This combination become AI agent. Simple. And when multiple agents, tools, MCP servers, and workflows work together, it becomes agentic AI. How simple is this? How simple is this? Cool. Okay. Now move forward. Using agentic AI in DevOps, what we can do, we can monitor Docker containers. We can monitor Kubernetes clusters. We can automate infrastructure tasks. We can troubleshoot issues and we can perform AI driven operations using agentic AI. How? Let's see in the demo. Okay, let's come to the demo again. I have created another file which is called agenticai.py file. It's a simple Python file, right? Till now, our LLM was only generating text responses. But what if I ask, show my running containers, get logs of a containers, check Kubernetes ports? Can normal LLM answer this? No. Why? Because you already know LLMs are trained on past data. They cannot directly interact with our live system. So now we need tools. Here I used LangChain. LangChain is a agentic AI framework. Helps to combine LLMs and the tools to create the agent, basically. Right. And here itself, here we are importing Chatolama to use our local LLM. We import tools to convert Python function into AI tools and import create agent, like to combine LLMs and the tool to create the agent. And we import subprocesses. Subprocesses basically it's a package that runs command on your terminal. It allows Python to execute terminal commands basically. For example, like docker ps, kubectl, get sports, docker logs, any commands you can run. And system prompt, you already know it's exactly like your generative AI we already covered. Now, come now. See this. Uh, See this first. See this function. This is normal Python function. You already know. If you know Python, you can know. But we add the rate tool at the top of it. Why? Because this at the rate tool LangChain helps to convert this function into the tool that AI can use. So with this at the rate tool, this function, Python function become the tool itself. So as of now, I have created few tools, I can say, show running containers to list the containers, show containers log by name, inspect containers, and few Kubernetes tools, list pod, describe pod, and get the events. So let's explore one by one. Inside the inside this tool, we are running Docker commands. You see, Docker PS. Sub process takes everything is in the arguments. So we just passing commands as a arguments. Docker PS to get the output, and we store the output in the return, and it will come here, right? So these tools I have these tools help AI interact with Docker and Kubernetes. So AI can now check containers, read logs, inspect issues, and now the chat olama. In the chat olama, here we are loading our local model using olama basically. What's our local model? Gemini 4, right? You already covered this just 10 to 15 minutes before, and we use temperature basically here. Temperature control randomness, like randomness of our output. So we the value of temperature lies between 0 to 1. So 1 is the like pinpoint answers, very strict answer, direct answers, I can say. And with the 0, we get loads of extra stuff. So I just mentioned 0. 0.8, so we can get some outputs in 1 or 2 lines, right? And the tools we used. Here we are registering all the tools that AI agent can use. And here, this is the most important part. How the agents created LLMs and the tools with the LLMs and the tools. So what we do, we created LLM, we created tools, and with the LangChain create agent, what we create agent. So create agent. Here we convert our LLM into the AI agent, right? Got it? And if you see below, you already familiar with this code. You just see this code here itself, right? Remember. So like while loop again and again to communicate with the agent, right? Agent invoke the intelligent AI agent, right? And messages, like we are passing user inputs, and then it's processing and print statement printing the messages. Let's see the output right now. So this is, so I have executed Python agentic AI.py file, this one we just shown, right? And ask about show me the list of containers. and see the output. Here is the list of all containers, including those that are currently running and those that have stopped. See, how cool is this? How cool is this? I ask, there are the container ID image. See, you can see by yourself. Like it's automating the DevOps part basically. Now, I just ask, give me the list of pods in default namespace. I'm asking the list of Kubernetes pods which lie in default namespace. See, the list, the pod is in the default namespace R. There is one pod basically I have created, and it's the status. See, the it gives the status as well. Clashback loop of this. It seems like the pod is experiencing issues. Would you like to get more details about it? See, it asking again, like, would you like to get more details about it? How cool is this? You built a AI agent, right? How cool is this? Right. So with this, you built a AI agent, right? I hope you understand this. I will be giving one proper PDF file so you can perform this generative AI and agentic AI labs. So to get the PDF, you have to join our group basically. So to join our group, just scan these QR codes. First, scan WhatsApp QR code to join the WhatsApp because I'll be sharing both the labs, Gen AI, Agentic AI labs in the group after this session. And then you can also scan LinkedIn. You can also connect with our group on LinkedIn. And if you want to see this session again, then you can go on YouTube and see this workshop again. It will be helpful for you, right? I'm giving you 2 minutes just to scan those QRs, connect with our groups, and let's build something together. I hope you all scan those QRs. Let's move forward. You already completed this. Okay, tell me honestly, this workshop, you get the knowledge from this workshop. Tell me honestly. So there is a one feedback form is here. Scan this QR, share your feedback. If you feel this workshop interesting, valuable, knowledgeable, share your feedback so we can improve us in our further sessions. I'm giving you 2 minutes. Scan this QR, share your feedback. I hope you all shared your feedbacks. Thank you so much. Thank you so much for joining with the CNCG Noida. Thank you so much joining this session. Happy weekend.